Good morning, students. In our previous lecture, we discussed about the tolerance, then types of tolerance. So let's see the difference between unilateral tolerance and bilateral tolerance. So as we know, if we give tolerance at one side, then a side of zero line, then it becomes unilateral tolerance. And if we provide the tolerance on both sides of zero line, then it becomes bilateral tolerance. So let's see the difference between unilateral tolerance and bilateral tolerance. At first is the definition. So when we provide both limits are on same side, then of zero line, then it becomes unilateral tolerance. That type of tolerance are called as unilateral tolerance. And when we provide uh, one limit at one side of zero line and other limit at other side of zero line, then such type of tolerance are called as bilateral tolerance. So this is the first point, definition. Then second is that sign use. So for in case of unilateral tolerance, for both limits having same sign, either plus plus or minus minus. And in case of bilateral tolerance, there are the different sign for both limits, plus minus plus minus. After that, the next point is manufacturing. So with unilateral tolerance, it will be easy to operator for manufacturing of job with unilateral tolerance. And with bilateral tolerance, it will be time consuming for operator. And the fourth point will be the diagram. So this is the difference. After that, next point, that is the deviation. So let's see what actually it is. Deviation means, so this is a deviation. Deviation can be defined as algebraic difference between actual size and basic size. So here in this in this drawing, so dotted line, this is the basic size, or it's also called as zero line. So that is, the dotted line is called as zero line. And difference, algebraic difference between actual size and corresponding basic size called as deviation. So this is deviation. Then there are the two types of deviation: upper deviation and lower deviation. So in this diagram, upper and lower deviation for hole, and as well as upper and lower deviation for shaft. So upper deviation, that means the difference between maximum limit and basic size of component, called as upper deviation. So here, if we consider example for whole, then upper deviation is nothing but difference between maximum limit and basic size. So maximum limit of whole minus basic size, so that is called that is called as the upper deviation. And lower deviation is nothing but the minimum limit and basic size, that is the lower deviation. So if we consider example of whole, then lower deviation is nothing but minimum limit of whole and basic size, that is the lower deviation. So if you take example for shaft, so upper deviation is nothing but difference between maximum limit and basic size, called as upper deviation. And if we see if we consider upper and lower deviation for a shaft, so upper deviation for shaft is nothing but difference between maximum limit of shaft and basic size, called as upper deviation of shaft. And lower deviation of shaft is nothing but minimum limit of shaft and basic size, called as lower deviation of shaft. So this is upper deviation and lower deviation for shaft and hole. After that, next one is fundamental deviation. So fundamental deviation is the upper or lower deviation which is nearest to zero line for either hole or shaft, called as fundamental deviation. So this is fundamental deviation. Then after that fundamental deviation, next that is the basic shaft and basic hole. So basic shaft, it is a shaft whose upper deviation is 0, or where maximum limit of size is equals to basic size, that is called basic shaft. So that means upper deviation is 0, upper deviation is 0 for shaft, and maximum limit of size is equals to basic size. That means here upper deviation, if we consider example of shaft, then basic shaft is nothing but upper deviation is 0. So that means the basic size and maximum limit will be exact same. And basic hole means here the lower deviation is 0. Lower deviation, that means the minimum limit of hole and basic size will be exactly same, called as basic hole. So these are the two concepts: basic size, basic shaft, and basic hole. That is the fundamental deviation.